Got it.
So you got me?
Yes, we can hear you now, and you can now start the presentation about water.
Yeah. All right. Sorry for the delay. It's always tricky to open these kind of events.
Yeah, we're still trying to figure it out, but please go ahead. Over to you.
Yeah. All right. So I was been asked to have a little chit chat about water and coffee, and a little bit also because a lot of us are stuck at home. So what about the home baristas and all this chemistry in the world around water and what we can do with it? So that's a little bit the basics of this short lecture. First of all, we all know that water has a very important impact on our drinks. So if you look at it, we have the chemistry of the water, which we could easily represent as being on a positively side of the elements, the chemistry. You find calcium, magnesium, which we all know as the scale minerals, which are killing our machines because they scale up. But it's not only them who scale up our machines. You need from the other side the carbonates, the buffer, like Maxwell introduced us some years ago. So calcium carbonate is our main problem if we look at technical side. But meanwhile, also from studies from Maxwell and Christopher, we know that we would love to have as massive as possible calcium and magnesium in our water, because these are just the two elements which will be going inside the bean, the fines of the bean, and pull out these fine flavors and aromas. So, because whether you like it or not, making coffee is always a chemical event. So we have to take a knowledge about that. Calcium will bring brighter stability. Magnesium will dive a little bit deeper in the coffee, but will also as fast pull out some of these less ideal elements. Now, basically view how water impacts on tea. It's right in your face. You got it visually. So on the left side here, if I'm in front of the screen, I got a green sencha tea. This one has been brewed with about 90 ppm minerals. That one had 250. Just by the look at it, you'll see that it's definitely not the most beautiful drink in the higher TDS. Same on the other side, you got Earl Grey brewed with a low TDS mineral, 90 ppm. And you have it brewed with the same 250. You have something black like coffee, greasy. And that will make the difference about, well first of all, the taste of a product is already 80% covered by the eyes. If it doesn't look good, most chance that it won't taste good, and that's already the reality. But here also in tea, you will cover it up, and you will notice that the tea taste will completely different from the one from the other. So when you brew coffee, is it filter coffee pour over or espresso, you will definitely see notice difference. And coffee is in a few seconds, 24, 30. For espresso, a little bit longer for filter. You will develop body, taste, aroma, and color. And all of that is a chemical reaction. Give you just an idea on how water impacts. When you brew coffee, it's about volume of water going through over a certain period of time. So if you look at my ideal water brew was here between the 18 and the 22%. So if that was my initially brew and I had it on the right side here, I did exactly the same brew, but with a different kind of water here. That means you see it's only about 2/3 went through the filter. So it will take a longer period of time to get through, which will bring my coffee from my ideal world here, balance between bitterness and fine flavors and aromas. It will move it up where bitterness will be overwhelming all the fine flavors I had in my cup. So that's one of the reasons why a coffee you had so great in a coffee shop and expect so much at home, suddenly it doesn't taste like this. So just the difference of water, you see also how the coffee reacts differently. It has a direct impact we should be aware of. Now, let's go for the nerdy or the basic barista home. Before we go for a crazy chemical playground, let's invest about $30 or euros, or even less than that these days online, in a basically good TDS meter. TDS meter, it's a magical word, TDS. Everybody's in the world is now talking about TDS. It's about measuring conductivity. It puts a power between two probes and it measures how fast it moves, and it will convert that into ppms or equally milligrams per liter. It's the same value. But it doesn't tell you what is in the water. Now, as a rule of thumb, in average, in a natural water, you would expect that of that TDS, you would have that conductivity, about 80% would be hardness minerals. In that water, you would have about 3 to 4 against 1 ratio, calcium to magnesium. That's a natural balance. Why it's so much more calcium? Well, because there's more calcium in the world than there is magnesium, and it's all over the rocks and all of that, so it's dissolved. And the pH will be mainly about 7 to 8.5. So we have now a natural product, which is a coffee bean. We have water, which is a natural product. So I'm going to challenge you one thought. Why would you want to turn this into an artificial chemical liquid? And this is a little bit, including myself, the barista nerds, going with extremely crazy mixing of water, minerals, and all of that, and mainly without understanding quite what we're doing. So it's chemistry, and my focus here today is to bring it at an understandable level and as simple as doable for you to have more time to enjoy a great cup of coffee instead of playing with chemistry. So what about your daily tap water? It might be already quite good. I have been all over the world, and here you have some results of my measurements online. So in Boston, I had about 38 ppms of minerals, so milligrams per liter, out of the tap. Of course, we had chlorine, chloramine. That tastes awful, but it's easy to handle. Or you have a basic carbon filtration. I would prefer it also with a sediment filtration with it, if it's online. Or you take a jug of water and you let it in the open air for a few hours. Most of the chlorine and chloramine will disappear, and you can use it. And chlorine, chloramine, you have it in most of the countries because we add it to keep the water potable up till the tap. Seattle, 45 ppms. New York, 55. Stockholm, 100, 110. And the reason why I put Oslo in blue is because on a regular basis in the world traveling, people say, oh, we want to have a water treatment that will boost our water up to the high levels of the Nordics, and like Tim Windelboe. Well, Tim Windelboe in Oslo, he has only 50 ppm minerals coming out of the water tap. So there's no need to push it. Rather try to understand what you're doing and how you play with it. Next to that, of course, you go to Orlando, 220, Amsterdam, 320, and we can go up to Copenhagen, 480. In Belgium, I have an area with 550. So it's about understanding, first of all, what do you have out of the tap? And before you start changing or going to do crazy expenses, buy you a TDS water, $30 investment, and check what you have out of the tap. That would be a first thing to work on. Now, I can understand this is the report of the London tap water. And if you want to know more, in most countries, you can have free of charge online a detailed water report from your water supplying company. Ask them. They do the measurements daily or even sometimes multiple times per day, and they will give you an average report. So how to read about this? If we're talking about alkalinity, that is what we mainly know as carbonate hardness. Here it's in hydrogen carbonate. You have about 312, 330 milligrams per liter. That is about 17 degrees carbonate hardness, calculated. We have calcium, but calcium you have to convert it before you know what you're doing. Similar hardness, total hardness as calcium carbonate. So here we have 343. Converted, that would be about 19 German degrees total hardness, or 19 grains per gallon. It's quite close to each other. pH is of interest, 7.2, as noticed positively. And technically, we're also going to look about chlorides, 40 ppm. Conductivity gives me, if I convert it, a roughly view on the TDS I can expect. In this case, about 390 ppms of TDS, if I put my water TDS meter in a glass of tap water. And then sulfates, it's also more about technical side, we're looking at those. So it's about a little bit introduction, understanding your tap water quality. Now, what can we expect if we have a certain water quality on board? And I'm trying to keep them up in my timing, so that's why I'm speeding up a little bit. I hope I will be having the potential to go through all of it. Water with a TDS less than 40 milligrams per liter or less than 40 ppms. If you go to filter coffee, you will have clear, pure coffee with the finest flavors and aromas. Limited body structure. In the espresso, you will have lack of body if you have a low mineral concentration dosage. So if you only go for 7-8 grams for a single espresso, you will have some structure, but especially the acids might be dominating. So here you're playing Formula One, fine flavors, aromas, more acidics. If you screw up in your coffee, brewing time, pouring time, grinding, you will definitely find a difference in the taste. When your water is up to 50 to 100 milligrams, and this is where I like to be playing personally, then your filter coffee will still be clear, pure, but have more balance in the coffee with still the finest flavors and aromas. On the filter, I would love to be rather 50, 60s. On the espresso, I would love to go more to the 100 milligrams or a little bit up. And then you will have more body structure and more balance in the drinks. Still, the finest flavors and aromas will emerge in the coffee, and you will have more stability. So this is where I prefer to play, as this is where I'm getting more ease and more balance and stability and all of that. If you have your water with a higher TDS, 100 to 200 milligrams, and notice everything you go above 100, 120 ppm, and you put that in your espresso machine, you will start scaling your machine. So understand that is something you have to accept, or you can play with a different water setting. On your filter coffee, you will have a richer coffee flavor, more intense balanced structure, but you might have less of the finest, absolute finest flavors and aromas being developed, because together with more minerals, you will always have more buffer. And that buffer is blocking also these changes of these more acidic oils to come out. So they will block it a little bit. Espresso, you will have, with more calcium, magnesium in the water, you will have more intense body, structure, and balance. And still, the subtle flavors and aromas, they come up, but the more you go higher in TDS, the less you're going to push them out. But that might not be a problem, because you will have more balance in your drinks. So nothing wrong with that. My personal let's say, ideal world, I would go to that 15 to 100 milligrams. And similar for tea, it's the playground I like to play in. And when I'm talking about the playground and where I like to play in, it's also a little bit to bring you up to another view. Remember, I said to you, everybody, would you be a chemist, or would you go playing for the great quality of the water? So it's about thinking, how can I manage to get this type of water available? There's one way to make that kind of water available and produce it. It's to go with reverse osmosis. Reverse osmosis is widely known, and it's available in all kinds of ways of technologies. But know that when you work with reverse osmosis, you will remove 95% of the minerals. That means you will end up with a water which would have 10 to 20 ppms of minerals. So that might be a complex solution to get back up. Low budget system will be wasting up to more than 90% of the water. That means that when you have 10 liters of water, you will only keep 1 liter to work with. In these days of water sourcing problems, that might not be the ideal world. Yet, if you only use 1 liter a day, it might be okay for you. Professional average would be 75% wasting, so 25% recovery. Today, high performance systems are recovering 50 up to 80% of the water, so only wasting only more 20%. And then it makes sense for nature because you also avoid using chemicals, and you just give a little more concentrated mineral water back to the nature. When you want to raise these low TDS waters, there's one way to do it. There are cartridges in the market. I think every brand product manufacturer has a kind of cartridge which brings back minerals into the water. Problem is you cannot control them, and it's not stable. Depending on the pressure, the flow rate, time, temperature, the quality of the incoming water, and so many more variables, you will have more or less low, but as often very high differentiations in the quality of the water coming out. So it's there, but it's not focused on bringing you stability today. So if you don't have anything else, and then you can work back off later, okay, but it's not the ideal world today. Another way to develop your the nerdy baristas we can develop our water is by demineralized water and use our RO water, and you're going to start mixing yourself. And there's a little bit also where I noticed on the championships, people, baristas saying, I have boosted my water with 50 ppm of magnesium. And by the way, do we need to boost our water with magnesium? There is one big reason why everybody's talking about it, because one company in the market, business-wise, to make profit, has boosted that knowledge and done a great marketing into the field. But as said, coffee is a natural product. Why would we screw with nature if the nature comes anyway with water that has some magnesium and all of that? We're going to build up the same. But if anyway you want to boost it yourself, most of them would be going to the grocery and buy maybe magnesium chloride. Well, if I look at the bottom, I'm going to raise the TDS with 50 ppm. That means that in reality, I have added 13 ppm of magnesium, but 37 ppm of chloride. That means that if I'm going to put this water in my espresso machine, I will destroy my espresso machine from the inside and forget your warranty because you're over the limits of the warranty claim. So understand that if you're going to play in these chemistry levels, similar with sulfates, you might end up with quite something completely different. Another point of that one is by adding these magnesium chloride or whatever, it makes the water taste more sweet. For your info, breweries are adding chlorides to their water to make their beer taste more sweet at the end in the whole chemical reaction of the brewing. And we can expect something similar with your coffee. That means that is the final quality of the final drink of your coffee, is that the result of what the great coffee beans, or if it's a result because you have been cheating with the quality of the water? Ask yourself that question and be reasonable about it. Now here again, it's about playing the chemistry guy. It's not, I don't think it's our main focus. I've also looked at the mineral dosage packages, remineralization packages, which are available on the market. Last year in Boston, I collected samples of all of them and start testing them beyond the standard. So from the basics as a barista, nerdy barista, looking here as this blue square, I would say, oh, great tools, because, okay, it's 6.2 pH, I can live with that. 160 ppm, okay, it's doable for espresso and so on, it's nice. Only 95, 105 on hardness, calcium and magnesium. Well, that sounds good. And only a very low carbonates. Sounds great. Personally, in that case, I already start to worry because the difference between all of that makes that something else is filling up that bucket. And if as I continue testing the water, what I notice is that third wave water and coffee water are using to compensate a lot of sulfates, and where GC water or the formal Cirqua is still using a high level of chlorides. And that again, if I take the full package and I drop this into my espresso machine, it will destroy my machine from the inside. But what I found even more personally problematic. All of these had a chemical aftertaste when I taste the water's pure. So if you want to go for those, be my guest, go ahead. It's not a natural water you're creating, but at least you're creating something. But also taste the water and have it purely taste. And that chemical aftertaste, I cannot, it must have also impact on your drink. So here you develop something which is in the basics looking great. In the whole picture, I'm not so convinced, unfortunately. So they're on the market, easy to handle. You have 1 gallon of demineralized water, and you add 1 dose of those products. Your kettle for your cold brew will probably not die from it. But here again, a question: why would I do this? There are other ways to get to the objectives. So, as I just had noticed a few times, what is your main focus? Is it to be a water chemist, or to brew and enjoy that great cup of coffee over and over again?
Was incredibly informative and valuable. I think a lot of people have some questions. Are you ready to take some questions at this point?
I had a very communication. I hope everybody else had listened better, heard it better.
Yeah, go ahead. I mean, if you want to just finish the presentation, that's no problem. We can prepare some questions for you in the meantime.
Sorry, I have something which is extraterrestrial on my headphone.
Can you hear me? Yeah. Can you see me? Okay.
Yes, I'm still there.
Just finish the presentation. We're going to have some questions in a moment from the audience. So I'll be ready to take some questions.
I can take some questions, but I have 2 minutes to give you the good alternative solution for the audience. Is that okay for you?
Go ahead. Go ahead.
Okay, because I still have nerdy something in that. So basically, what I wanted to bring to everybody is, if you keep on changing the fundamentals of your brewing, you will never get anywhere finally. So you will only be busy to continuously fix crackings in the wall and not get a great coffee. So an easy way to get to, and for the home barista certainly too, it's something simple, is buy you some bottled water. That's one more way. Look at the label of the bottled water, and here you see different brands already, and look in your shop what you can find, and those might be close to your ideal world. And another way to do is basically mix. For example, my Brussels water has 450 ppms. I buy a bottle of Spirain. So if I have a bottle of Spirain 1 liter and I'm adding 0.25 liters, so 250 ml of Brussels tap water, I got a TDS about 116. Easy to handle, and you don't need to go crazy chemistry. And you can always double check with your TDS meter and play with it as well. Same with a Boston and Evian water, for example, or even 2 bottles of water and mix them together. It's much more easy than a chemical development. Another way, very interesting for those who have a high TDS, recently it's still they're shipping out the first pre-orders, but I hope soon I will be able to order my jug. Maxwell brought in the peak water jug, which is a deionization. Yeah, Maxwell Kelowna is jug, the peak, which is pulling down the TDS. It's deionization, it's ion exchange, taking out the minerals of the water. And with an easy adjustable bypass, you can adjust your jug to a certain level of TDS. If you need a higher volumes of water, and this kind of bottles like Claris Prime ideally would be running 2-3 liters a day, then these might be of interest, and you can have higher volumes at the lower cost of per liter. Of course, the first buying cost will be higher, but the capacity is there also to play with your water. So these are 2 ways also to easily bring down the TDS, the minerals of the water. So I can advise, I have not been able to test it yet, but I had a good chat with Maxwell during the Danish Coffee Festival and have been able to taste the coffees. And it looks great, that jug, and I'm looking forward to have my hands on one as soon as possible. So water comes in very classical. This is a graph on the water quality I've been showing for more than 15 years now. Ideal water, about 70 to 150. Filtered coffee would be rather the 70s, 60s, 70s. Espresso would rather go higher, but I would stay around my 100. But this is still an ideal world for coffee and tea. So that will be my presentation completely, and I gladly take more questions from the audience. What I'm going to do, I'm going to try if I can have, because the sound was not that great, could I have chats? Yes, if so I can give answers to all of the questions on the market. So please, yes, go ahead. Any questions on the field? Hello. Yeah. Are there questions from the audience?
There are questions. Just 1 second.
Now I have a pure sound. That's great.
Can you hear me well?
I hear you perfectly.
Here we go. What is the best way to have a control on the ppm, bringing it to 50 to 100 ppm on a water coffee shop installation?
If you're in a water coffee shop installation, you're running probably quite some water. Today, the most stable solution is still a reverse. If you have a high TDS coming in, of course, is to go with a reverse osmosis and have a very good controlled blending back of filtered hard water. You're only going to add, in average, you're going to bring back about 10% and 15% of the original tap water, which is a very low concentration. But by having 10% coming back only, that means that even if the water on the incoming side would be fluctuating 100 ppm, it could have maximum a 10 ppm fluctuation on the outgoing. So you will have the closest to the most stable solution.
All right. That sounds like a very good answer. Let's have another question from Igor. What GH and KH would you recommend for brewing coffee?
You're talking about so pH and KH, so the total hardness and the carbonate hardness. So the pH, the acidity?
GH and KH was the question.
Okay, total hardness and carbonate hardness.
Mm-hmm.
If you look at the WBC standards, those guys would love to have about 80 milligrams per liter on total hardness and about 40 on alkalinity, carbonate hardness. That would be for going through the espresso and all of that. And in a similar range, and like I said, I wouldn't be, if you can work with a natural water, your TDS, about 80% of the TDS will be your hardness, roughly, and about 80% of that 80% will be about alkalinity, carbonate hardness. For me, that's fine, and there's no need to jeopardize with this. The reason why the market has been playing and talking about that 5 degrees and 4 degrees comes from, again, from the industry, because the industry needed that for the carbonate ion exchange softening as a reference. But for the real coffee, 40 and on alkalinity, about 80 on total hardness, GH, it's great values.
All right. And we have another question here. For cold brew preparation, are there any commercially available waters you recommend? Fiji water, Aquapanna, etc.?
Here again, the same story. I would love to see my water as well for filter and espresso, but let's say for filter coffee and cold brew, around the 60 to 80 milligrams per liter. Go to the supermarket, check on the label of the bottle, and buy you what's close to that. And maybe you might want to buy 2 brands and mix them together, like I've done in the example, to come up that. Every region has its own, but be aware that sometimes, and certainly if you have shop private label waters, the different format of bottling might have a different water quality. Example, in Belgium, we have Colruyt. The 2-liter bottle has about 800 ppms, and the 200 ml bottles have about 200 ppms. So always watch the label on the bottle and check what's in it. That's the easiest way.
So actually, I was told by a coffee vine subscriber not too long ago that Evian has the best composition for brewing water. Is that correct?
Well, let me go back up. Evian has a very high TDS, quite high TDS. I'm going back here. If you still see my screen, Evian is in the middle. It has about 360 ppm minerals.
Hold on a second. Let me just go back to your. Can you share your screen again, please?
It's still on.
There we go.
So Evian has 357 milligrams of minerals, but it has a lot of buffer carbonates. So I wouldn't advise this as being the best water for your filter coffee, because probably your tap water will have a better result than this.
It's delayed. All right. Where is my feed? Let's see. More questions. Let's see. Can you still hear me?
Yes. I'm still online.
Okay, great. My water is between 30 and 50 ppm, a bit south of Oslo, Norway. What do you suggest to get a greater body brewing coffees with this ppm? Well,
you're lucky for filter and tea, so that's fine. If you want to have more body, I would say if you're a home barista, buy you a bottle of Evian, for example, and mix them together. So I think it's the next slide. Yes. So if you have about 30, so that would be the example of. Let's say if the example in the middle, Boston water, something similar, and Evian. If you would add about 25% of Evian water to your tap water, you will have water which would have about 100 ppm, and you will definitely have more body in your drink.
Okay. Did that answer the question? I am sure there's so much more to learn about this. And is it true, I'm going to ask you a question now, is it true that the coffee in Iceland, the water in Iceland is ideal for coffee brewing? A lot of people say that it might just be an urban myth, but because it's so rich in minerals from its volcanic source, a lot of people say that Icelandic tap water is the best.
Well, I need to see a water report, but as far as I know, Icelandic water is mainly low TDS water, in the range of the 60 to the 100s. That's the notes I had. So that is close to that absolute ideal perfection. It's a little bit like in Stockholm, 100 ppm. You just want to control it, and beyond that, yes, it's fine quality.
All right. We have a question here from Patrick. I'm going to just put it on the screen. Can you quickly go back about the process with tap water and osmosis? What numbers to check and how the math works? So maybe we can go back to that slide. Maybe that was not so clear to everyone. It's quite a lot of information to take in. I think it'll be very valuable for everyone to be able to go back to this presentation at a later stage. We're going to post all of these presentations as YouTube videos, so you can go back and check them out at a later stage. So everyone can take their time to find the information that they needed. Let's see, Ronny, do you have that slide available?
It's about the mixing.
Let me just go back to the question. Yeah, the process with tap water and osmosis. You had a slide on that, right?
Yeah, mixing. Well, it's about mixing both waters together.
Mm-hmm.
So yeah, that's the same what I've been talking now. Just here, it's about, okay, if you have a low TDS, and that could be osmosis water and tap water. So there's easy mathematics to be done. If you say my osmosis water will be having roughly about 20 ppm of minerals left over. Mm-hmm. If you're gonna add a certain amount of the different water quality, it's about doing the math and joining them together, and that's one way to do it easily. So no need to go and wait out small amounts of chemical compounds and all of that and doing all of this. Use nature. And so RO water is just 5% left over of all the minerals present in your original tap water. And then you add a little bit back from your tap water on a controlled way, and you can bring it up where you want to have it. And this is an easy way to have a water quality where you can say, okay, let me fix that one as a base. So I will always brew, for example, with water of 60 ppms, easy to be made. I got RO water, I got my tap water, I mix so much, that's going to be base. And now I'm going to focus only on my coffee and on my grinding, and on my temperature and on my pouring. So I removed one big variable, and that's what I advise to everybody. Water is not water that's going to make your great coffee. Water will help you to bring that basics. So decide in a certain moment for, okay, this is going to be my base, and now